record. All right, so taking the derivatives, I gave you this big, long-ass thing. It looks nasty, but it's not that bad. So right now, the only thing I've taught you is the power rule. So when you want to take a derivative, you multiply, you take whatever the power is, you bring it to the front and you multiply. So here I would do 7 times 2 and make 14. And then you subtract 1 from the power. Now over here, it's a little more complicated. So I'm gonna do the work down here and then erase it. I'm gonna multiply by the power, which is 4, and then subtract 1. The problem is you have to do 5 over 6 times 4. And if you remember your 4th grade math, maybe you don't remember, 4 and 6 are both divisible by 2. So I'm gonna cut these numbers in half. Half of 4 is 2, half of 6 is 3. And now I multiply the numbers on top, 5 and 2, and make 10. And then I multiply the numbers on the bottom, 3 and 1. So, and yes, you do have to reduce them, right? So you multiply by 4, and you say, I'm just going to get 20 over 6. Same shit, right? If you multiply by 4, you get 20 over 6, cut them in half, right? 10 over 3, you get the same thing. Subtract 1 off the power. So this is what you do when you have a fraction in front. What happens when the fraction is a power? I have to multiply again. Multiply by the power, subtract 1. Multiply by the power, subtract 1. Ooh, it's going to be more complicated. So first I have to do 12 times 2/3. Make it 12 over 1. The cool thing is that 12 is divisible by 3. Yes, you can make it 24 over 3, same crap. Put 3 into 12, which is 4. 4 times 2 is 8. So that's what 2/3 of 12 is, right? Multiply. Now I have to subtract 1. I have to do 2/3 take away 1. You're going to get a lot of fractional exponents when you do derivatives. There's going to be fraction powers all the damn time. You have to know how to handle them. But the easiest thing to do, you can only add and subtract fractions when the bottoms are the same. And I just showed this to my remedial class. So instead of a 1, make it 3 over 3. Whatever bottom you need, just make it that. If this bottom was 5, I'd use 5 over 5. If this bottom was a 7, I would make it 7 over 7. So 2/3 take away 1 is negative 1/3. So that's the new power I'm going to have. So I multiply by the power and subtract 1. There's my new power. Now I'm going to do it over here. I'm just going to keep doing the same thing again and again and again. Multiply by the power. Negative 5 times negative 3. Power comes up in the front. So you get positive, right? Negative times negative is plus. 5 times 3 is 15. Now I have to subtract 1. Here's where you have to make sure you don't do any dumbassery. Negative 3 minus 1 is not minus 2, right? If you owe me $3 and you owe me another $1, you owe me $4. So make sure you subtract right. Now this last one, I'm going to do special. Because you're like, you're supposed to multiply by the power, but there isn't a power. What the hell do you do? Well, there's a 1 there. No, there's not. There's no 1 there. There is. There's an invisible 1 there. You don't write this 1 ever. When you just write x by itself, it's x to the first. There's only 1 x there. So you multiply by that power. 8 times 1 is 8. And then you have to subtract 1 off that power. And now you get 0. What the hell is that? X to the 0 is BS. But x to the 0 is 1. Anything to the 0 power is 1. So that x is just going to drop off. So when you take the derivative of something that only has an x in it, the x will go away and you get the number in the front. Now I'm going to deal with the last number. You have a negative 4, and I want the derivative. But there isn't an x there. Oh, we can cheat. We can put x to the 0 there. There's no x's there, right? There's no x's there. If you multiply by the power of 0, you get 0. So the derivative of any constant, any fixed number is 0, no matter what that number is. Even if that number is radical 3. And like, what's the derivative of radical 3? 0. Those are rules that I'm going to list for you in a second in the class notes, okay? So multiply by the power, subtract 1. Multiply by the power, reduce, subtract 1. Multiply by the power, reduce, subtract 1. Multiply by the power, subtract 1. Multiply by the power, subtract 1. It goes, the x goes away. And then there's no power there at all, so it goes away. So this is a basic. This is as easy as it gets. I will have one like that on your test, I promise. So this is how you apply the power rule. I'll do a more complicated example in a minute. Okay, so the harder example, which has all the questions on the worksheet. A radical x, x on the bottom, weird-ass radical with numbers, another x on the bottom, the weird-ass smiley face thing, and then you got the pi. It's like, what do you do? What do you do? First, I don't take the derivative. It's like, but the problem is to take the derivative. You're supposed to take the derivative. I cannot take the derivative of any of these things except that one and that one. I can't take the derivative of any of these terms the way that they are written. They are not in the proper form. So the first thing I'm going to do is rewrite them. Now, radical x, you're like, I don't know what the hell power that's supposed to be. This is the square root. It is the opposite of square, okay? The square is x to the 2. So this one is x to the 1 over 2. Those are inverse operations of each other, okay? So the radical x, you have to write as x to the 1/2. Now, the question is, what the hell do you do with x to the -2? But, you know, you should know a rule from back in the day. When you have something like this, if you move this dude up, the power switches. Like, how would you do 2 to the -3? You can't compute this like, it's -8. You just do 2 times 2 times 2 and make it negative. That's total bullshit. The way that you would evaluate a negative power is you would flip it down to the bottom and make the power positive. Now you can compute it. So 2 to the -3 is 1 over 8 because you can't evaluate a negative exponent in a normal way. So now what you're doing is the reverse. I have a positive exponent on the bottom, but I don't want it there. I want it on the top. So what I do is I move it up, but I have to switch the power back into a negative. So that's what I'm going to do here. The x to the -2 on the bottom has to come up, x to the -2. So the x to the +2, when you flip it up to the top, the power switches sign. Now, over here I have a 12. Again, I need x to the p. So now the million-dollar question is, where do these numbers go? I mean, I'm definitely going to have a fraction, right? Anything with a radical will have a fraction. So, but if you look at this example, there was a little 1 there, and there's an invisible 2 inside the radical rivet, right? I'm calling it a rivet, whatever this little thing is. So the number here is always the root, right? This is a fourth root. If there's a 3 there, it's a cube root, right? Third root. So this is the root. The root always goes on the bottom. This is just a regular exponent. This is x to the 3rd. So that 3 has to go on the top. So my rewrite here, the number inside the radical thingy is the root. It goes on the bottom, and the other number goes on the top. So you get x to the 3/4. Now, this is there to trick you very badly. So you learned in this one that the x on the bottom comes up and you switch it to negative. So here's what people will do here. But I'll point out that this is 1/2. This is 1 over 2. And if you think that the number 2 and the number 1 over 2 are the same number, think again. You can't do this. This is nonsense. You cannot take the 2 out of the bottom and move it upstairs. It's not a 2 anymore. I mean, it's not a half if you do that, right? It's now a 2. So who you move here is this dude. He comes up. So you have to leave that 1/2 there. This 2 has to stay on the bottom. You can't move this dude up. It becomes a different number. But the x to the 6th on the bottom can come upstairs as x to the -6. So here, this is a trick question. You're going to have this on your test, I promise. So 1/2 has to stay. x6 is what comes up as x -6. Now, nothing else can be rewritten. I have my smiley face x, and I have my pi6. Pi. I like pie. I don't like pie. Usually people put cinnamon in pie. Cinnamon nasty. Some people like cinnamon, I don't care. All I did, so you think, I'm done. I didn't even take the damn derivative yet. I haven't done crap. All I did is rewrite them. Rewrite, 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 rewrite. Leave alone, leave alone. You can't rewrite the first 4 dudes and then take his derivative and his derivative. It doesn't work that way. All right, you have to do the operation simultaneously. Now, I'm going to take f prime. Multiply by the power, subtract. Well, this is a half. Half of 8 is 4. And we're going to be more sophisticated, right? I have to do 1/2, take away 1. So that's 2 over 2. 1/2 minus 1 is -1/2. Don't rewrite the answer after you take the derivative. Leave it like this, all right? Don't get cute and go, I'm going to make this 1 over radical x. You can do that, but don't do that, all right? Leave it alone. Multiply by the power. 4 times -2 is -8. subtract 1. Minus 2 minus 1 is minus 3, right? Multiply by the power, subtract 1. Here, I have to do 12 times 3 over 4, just like before. Do 12 divided by 4 is 3. 3 times 3 is 9. So 3/4 of 12 is 9. Subtract 1 from the power. I don't like the way my 9 looks. It's bothering me. Gotta fix it. Come on, connect. There we go. So now I have to do 3/4, take away 1. That's not 1. Yes, it is. 4 over 4 is 1. 3/4, take away 4/4 is negative 1/4. Get a lot of nasty fractions here. Multiply 1/2 by negative 6. That's going to give me negative. Now, half of 6 is 3. Just watch your signs really closely. All right, positive times negative is negative. Subtract 1 off that power. Now you have to take the derivative of smiley face x. What the hell is this supposed to be? Multiply by the power. Smiley face times 1 is smiley face. Subtract 1, you get x0. So I told you, when you take the derivative of anything with an x, the x just drops off. So this is going to be smiley face. And then, oh, pi to the 6th. I got that shit all day, man. 6 pi to the 5th. Woo, this is so easy. It's stupid I got that. It's easy. Pi is 3.14. That is a number. That is a constant. And if you take that and raise it to the 6th power, you still get a number, which is a constant. So the derivative of pi 6 is 0. It goes away. And your final answer is this thing. The derivative of pi to the power is 0 because pi is a fixed number. So again, rewrite the terms you need to. If you got an x on the bottom, move it up, make the power negative. If you have a radical, the number outside goes on the bottom, the number inside goes on the top. And then you start taking the derivatives, all right? So always rewrite first and then take the derivative.